Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone, and thank you for joining us for this episode. This time we are going to talk about the testing of substation automation systems. In general, a substation automation system is a collection of hardware and software components that are used to monitor and control an electrical system, both locally and remotely. Substation automation systems are essential since they increase both the integrity and safety of the electrical power network. In this episode, we will discuss why testing is essential for substation automation systems and what are the various tests performed. In addition, we will address the challenges faced by testing engineers up to now and how to make the testing process faster and more efficient with automated testing solutions. With me to share his knowledge, experience, and insights into this topic is Thomas Schossig. He is the product manager for Omicron's StationScout testing solution for substation automation systems and an expert in this field. Hi, Thomas. Thank you very much for joining me for this discussion.
Hi, Scott. Good to meet you. This is my first podcast. It will be exciting.
Oh, you'll do fine. Don't worry. Thomas, could you give us a brief overview of substation automation systems? For example, what are the different parts or aspects of such systems?
To be honest, this is no new technology. I, for instance, started as a commissioning engineer already in the last century working on this. At the beginning, this was only telecontrol. So this is how it started there. And today, of course, it's much more complex and widely used. It consists of bay controllers in the field level, station level with central components. There are the remote terminal units, the RTUs, and an HMI, a local visualization, the human machine interface, where you can see everything. This all belongs to the substation automation system, so rather complex systems.
How does substation automation systems play a critical role in the power grid?
I grew up in a house close to a substation, and at this time, the neighbors worked in the switch room there. It was 24/7, every day manned, the substation. Today, we have unmanned substations, so nobody is working there. And everything has to be done remotely. So it's very important that everything works properly. Additionally, we have automation functions, synchro check, and other quite complex functions, and they all ensuring the reliability of the grid. So everything is extremely important.
Why is testing essential to the overall performance of substation automation systems?
Testing is very essential, and that's why a so-called bit test is done. So every single signal in such a substation automation system needs to be tested. And this is another very important aspect, there are safety-related topics as interlockings. This is something that avoids that dangerous actions could happen to the switchgear, to the control equipment, and that's why it's very important.
So you've described a few of the things that need to be tested. What are the essential tests that need to be performed?
We already talked about a little bit about the signal testing. So this means that every possible signal has to be tested. There are different conditions on, off. There are double point indications. So we have also intermediate position, and everything needs to be tested step by step. And the tests also cover the logics, the PLC there inside, so ANDs and ORs, also very complex systems as they are used for interlockings. And this all has to be tested, and those are the essential tests to be done during such a commissioning.
Thomas, how are these tests conducted, and when are they generally performed?
Yeah, when I started this testing there in the industry, this testing was mainly done during the commissioning, but of course also preparing everything in the factory already. And then after the commissioning, you have then there a site acceptance testing. So those tests, factory acceptance testing, the FAT and the site acceptance testing, SAT, mandatory and will be performed. Today, this even extended so that also once the system is in operation, there might be tests necessary. Why? Because it might be that something changes. In our today's substation, there might be some new feeders, changes in the grid, and those extensions also then need to be tested. So this is also important. And finally, a very important and a new topic is that we have now security issues. So it might be that I have a new firmware to be used for my substation automation system element there. And you have to load the firmware. And of course, after such an update, you have to test something because it might be, we all know that there can be something wrong in the software or something fail. That's why it's recommended to test even after this.
Okay. Are there any standards that specify how this testing is performed?
Yeah, it's a good question there. Compared to protection, where we do a lot of tests and also I did a lot there, there are no real standards where everything is described, also no industry standards how to do this. Of course, there are recommendations. You can say it like this, yeah. So for us, for instance, we are also working there together with colleagues in national and international standardization bodies, and there we create recommendations how to perform such tests there. So there is something. We cannot say that there is nothing. Nevertheless, in normal case, it's really up to the utility or to the service provider what to test and how to test. And of course, everybody wants to save time and everybody wants to know that the system works properly. And this is exactly that where we are, what we want to achieve there to have a good result. And that's why we are recommending their tests.
Okay. So what have been the challenges of performing these tests up to now?
In the past, this has been extremely time consuming. So you spend a lot of time, try, repeat, fixing errors, and then all these messages and all these indications to be triggered. So this is very time consuming. Every equipment in the substation has to be operated, to be moved. The protection has to be stimulated for the different indications, overcurrent, general trip. So there you spend a lot of time there. And of course, we all know something can be wrong. Some devices can be broken. And that's why it was extremely time consuming there.
Okay. Thomas, how can testing engineers best overcome these challenges?
Of course, also in the past, the engineers tried to solve the problems where they are faced with. And you see all those substation automation system guys, they of course are clever engineers. They build own Excel templates where they try to cover everything. They use some vendor-specific tools and everybody has its own tool set. And so they spend a lot of time figuring out everything. And that's why everybody tried to solve the challenges where they are faced with to achieve a good result.
Okay. You had mentioned before that the testing process was quite time consuming, which also presented challenges up to now. What are some of the ways that testing engineers have overcome this challenge?
Yeah, to be honest, they all the time really watched how the protection guys are doing it. They have the nice templates, they have the OCC or relay sim test files. They press a button, everything starts, and at the end they have their green check mark, and everybody is happy with the tests performed. Yeah, this is what they see, and they want to have more or less the same. Of course, it's not possible because those systems have another complexity and there are a lot of different tasks to be done. But this was the wish all the time, to have something like the protection guys, and that's why we also initiated to start thinking about this, how to support also the substation automation engineers, which in the past have been different one as the protection one. But now this is more and more also combined and mixing up, because in modern substation, you have combined devices for protection, automation, and control. So that's why this is growing together, and that's why there's definitely a need for testing more in the future.
So how is Omicron involved in testing substation automation systems, and what solutions are available to help improve testing methods?
Yeah, as already mentioned there, this is why we started to developing our product StationScout. So we have been confronted there with the need. Customers have been looking for solutions. They say, hey, I'm going now for ISC 61850 substation automation systems. I need support there. So they have been looking for something. And that's why we started to develop such a solution some years ago with a involvement there of the customers, which was very important for us to learn how they do it and what they are looking for. And the result is the product as we have it now.
What are the key aspects of the Omicron StationScout testing solution that make these improvements possible?
It's really that how do you start such a test there? You first of all want to see what is happening there inside. So we started with the visualization of the substation automation system, who is talking to whom, how are the IEDs, the intelligent electronic devices, communicating together. So this is how it starts, yeah, that we see, okay, there is the goose, there is this client-server communication as described in the standard, and this is already very helpful. And then, of course, the testing starts, and testing means that you are going to prepare the test cases, what you want to test, and you also then describe the different test steps there inside, so every signal there. And then, of course, you have it. You want to document the test performed, and for instance, in case of a security patch, you can repeat the test with the new firmware, and then you save, of course, a lot of time. So this is exactly this how we do it in the software there, that we are doing it, visualizing, preparing, performing the test, and repeating when needed.
Could you describe Omicron StationScout? You mentioned it consists of firmware and software. How do they work together?
Yeah, the test system consists of a hardware and a software. Better to say it like this. So the hardware is a very flexible and small device where you can connect to there with Ethernet ports there, and then you connect to the substation automation system there. On the other side, you have a control port where you can connect your PC to, and on this PC there is the software, the front end there, and there you can watch the system, start to simulate, but this all is done then with the hardware. And you can also connect a second software there to it if you want to watch it from different positions there. And so the system then visualize everything, and you can perform the tests then there quite easily with a user-friendly software at Omicron. This is very important. We have our usability engineers watching exactly what is happening there, how do the customers operate it, and that's why the software then visualizes, and you can start creating the test cases, finding issues, errors are indicated there, and then you can perform the test quite easily.
Okay. Can these tests be performed remotely, or do they need to be performed on site?
Yeah, it's a good question. There is something we planned it, or the implementation that we have it. As long as you have a connection to the test set there, connected to, this can be done remotely, and this is definitely also our vision to do it like this. Of course, we all know that not everybody likes it to do it remotely, and of course, if something happens, then you want to be on site there. So I know this discussion for a long time there. How about remote testing and to just press a button in your office? But I think it will be more like this in the future because the technology is available. And once the advantages have been found out, then it will be used more. Of course, we all know something. It's what is safety related. Then, of course, it has to be done then there on site, things like this. But I think this combination and some tasks then really can be tried out remotely. And for instance, when you know that everything worked well and you have then such a firmware update because of a security issue there, and then you try out the tests there automatically that you performed once during the acceptance testing, then I think this will be something accepted in the future more. But might be that in the power industry, the people are a little bit more conservative as in the other industries. In the past, it was like this, that the substation automation colleagues have been a little bit more flexible and open as the protection colleagues, but we will see how it develops. We are open to watch and to support the customers, whatever they want to do.
Can these types of tests be combined with other types of tests, or is this an isolated test sequence?
It is at first an own testing system, but we also delivering, for instance, there with every license the customers buy, they receive also ISmicron, a software as mentioned, operating also on a PC or also on this test device, what we have there. And there you can also perform additional tasks. And this also can be combined there, some advanced tasks, what the customers really like. So that's why we deliver also this additional software. Of course, in the future, there will be more. We are currently checking this and we have their visions on this to also combine this with other tests. But for the moment, this is how we test the substation automation system.
Okay. In the software, are there any tools available to users that help them perform tests? For example, like workflows or instructions about what to do next?
Yeah, it comes with a friendly user interface there, what absolutely helps, as you described, to define the steps and you see the order. There are also several explanations there in the help. So this definitely supports the user there. And of course, also watching then such a webinar there. So yes, there is that the workflow then is documented there. And also in the future, we have more ideas to support also our customers additionally. But for the moment, this is what we offer.
Okay. How long does all the tests that you need to perform on these systems, how long does that generally take?
Of course, this depends of the size of the system and the size of the substation there. The more feeders you have, the longer it takes. So where we've been, we did several trials with customers, preparing something, and then we see all the time, of course, the first feeder then takes some time that everybody is familiar with and learns how the setup can be done, how the test steps can be prepared. And then the other feeders, then they are much faster there. And then, of course, during some hours there, you can definitely then there repeat the test there and perform it. Of course, it depends, as mentioned, of the size of the system and, of course, the complexity.
What excites you most about StationScout testing solution?
For me, it's really exciting there because, as I told you, I started there as a young commissioning engineer there it was in the 90s there, and where we had, of course, already computers there, the first one. We had there some dirty tools and things like this, and we managed it, and it was a lot of fun, and it was definitely interesting. And when I compare it now to see what we achieved there with ISC 61850 and what are the opportunities, then I really see a progress there. And this is what I like to see, that it's now definitely easier, even with the increased complexity that we have now in our modern substation automation systems.
With your experience in testing substation automation systems, what do you see as future trends and upcoming challenges?
As already briefly explained, so we are now here in the ISC 61850 environment, the standard for substation communication and power utility communication, widely used, and of course more and more used. And this is something where we are involved for a long time in the standardization, and we develop testing solutions there, and we are quite active there. And this is a trend that continues. We see how the application of 61850 is extending there. We use it with renewables, we use it for substation to substation communication, and so on. So this is definitely a trend. Another trend that we see is that there's the wish to simulate something. So if something is missing, you all know there might be that we are missing components at the moment. Everybody knows how it is at the moment, not so easy to buy some things. Okay, then if I want to start working, I need to simulate a missing device. And that's why I really would describe this as a trend, that we have to solve problems like lack of devices. And last but not least, we also see two additional trends there. One is, of course, that the older protocols, as we use them for a longer time, like IEC 6870-5104, they are still widely used. And of course, this will not change from one day to the other. So that's why we also see a need for such protocols there. And also another trend there, and this is just to finalize this, we also see that, of course, testing in general changes, that people say, okay, why do I still need to test? Wouldn't it be, or why do I have to do a routine test? Wouldn't it be more interesting to monitor, to do a functional monitoring also of the communication and the substation automation system?
What can testing engineers do now to prepare for these trends?
The best hint is all the time familiarize yourself with IEC 61850, try to understand the concept, then you as a user can use it, can also use the advantages. Don't trust the vendors all the time. Better you try it out on your own and test it, of course. So this is something what I definitely can recommend there. We also see that engineering is very important. IEC 61850 describes the engineering. So there we create so-called SCD file, substation configuration description, system configuration description files, and they contain the information. And the better those files are, the better the testing and the better the implementation is. So that's why we also recommend check the engineering, try to understand what is happening there. And that's why this is definitely something what I would recommend every engineer there in the field, in the industry.
If there was one tip you could offer our listeners about substation automation system testing, what would that be?
A tip is always then, of course, to try it out, as mentioned there, to try it out in the office or to try it out online there, and then to understand the system and then to spend the time with there. And this is also something what I learned there, because the substation automation systems, they differ and at the different customers, at the different utilities. So none is as the other. So please all the time try to understand why this was made like this, and to really check, then go into the deeper details there and learn what was the intention there. And you will be surprised also how clever engineers had some ideas there a lot of years ago there. And that's why this is really something what I recommend. Spend time there together and check it.
Thomas, where can our listeners get more information about performing tests on substation automation systems with StationScout?
First of all, of course, can recommend to check Omicron's website, or there is also a page called StationScout.com. There you also have the opportunity to try it out online, to try it out on your own, to play with the system, to understand the functionality.
Interesting. Describe that a little bit. How does that work?
We wanted to deliver our potential customers the opportunity to try it out, because in PowerPoint, everything looks interesting, but I know that engineers want to see it and want to try it out on their own. And of course, we have another product there with ISmicron. There you can download a trial version and you can start to play with the software for 30 days. And this is very successful. The people like it because they see, okay, this is how it works. I like it, fine. And we wanted to have the same. Of course, here we have a dedicated hardware because we have requirements for cybersecurity. We need a powerful hardware for the simulation. So it's not so easy to download it there and to try it out. And that's why we have it here in our premises that we have there something installed and you can access to it. You can book a slot and there you can try it out. And there you can load the file that you created, your own file, and this will be not stored anywhere. It's just to try it out. And then you can see your substation automation system with our testing system combined. And then you learn how such a test could be performed. And we think this is very helpful. And this is what engineers want to see. They want to see with their own system, how it works, and to understand their system. And this is our approach.
Certainly encourage our listeners to try that out.
Please try it out there on the website. There we also find there additional webinars, something to watch there, explaining the functionality, where our sales engineers explain it, how to use it, what are the advantages, also very helpful. Interesting papers also to read what we published at international conferences there. So quite some information to learn more and hopefully also to understand and better also the need for testing substation automation system and the advantage there.
Now, in addition to webinars, does our Omicron Academy also offer courses on this topic?
Yeah, good point. We already had it in our traditional IEC 61850 trainings there. And now we are currently developing there a new concept there, which we adapted to the current needs there. And there is now also the possibility to learn the testing there and to really try it out on your own. And exactly there, the Academy there is a good contact to get in touch with.
Okay. So for courses about substation automation system testing, listeners can go to our website and look under training to find available courses.
Yes.
Thomas, thank you very much for joining me for this discussion.
You're welcome. It was quite interesting to discuss it.
Great. Thank you again. And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, including the testing of substation automation systems, and it offers you the matching solution for your application. For more information, be sure to visit our website at omicronenergy.com. There, you can also find more information about training courses and webinars offered by Omicron Academy. Simply look under Training. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.